We're going to look at exponential functions, and we're going to talk about two types of exponential functions. We're going to look at exponential growth functions and exponential decay. And the ideas with both of these functions is that if it's growth, it's going to generally be increasing to the right, and decay will generally decrease to the right. So, first thing we're going to do, get a little background on exponential functions, and they give us, for exercise 1, this function. And what you'll see with exponential functions is that the exponent is the variable. So when you're doing each of these parts for A, or where they give you numbers to input, you're going to be putting that number in as the exponent. So I got 8 times 2 to the second, then I got 8 times 2 to the 0, and then we have 8 times 2 to the negative first power. So I'm going to take the calculator, and just remember you got to use this button right here. That button will give you the exponents. So we got 8 parentheses 2 and putting the exponent of 2. So that answer is going to be 32. And then same thing, 8 parentheses 2, 0, you get 8. And again, try this yourself, make sure you can get that function to work. And then for the last one, we're putting in a negative 1. So you get 4 for that one right there. Now they want us to do the rate of change from negative 1 to 0. So we talked about rate of change a lot with linear functions. Maybe touched on a little bit with quadratics, but with exponentials we'll see this because the rate of change will help us determine what types of functions we have. So we got negative 1, 4 from our work above, and we got 0, 8. So in this case, if I do top minus bottom, I get negative 4, and negative 1 minus 0 would be negative 1. So it would be negative 4 divided by negative 1, which is 4. And if I do 0 and 2, I have 0, 8 and 232. So what you'll notice is when I subtract these, and again you can subtract it top bottom or bottom top, you get negative 24 divided by negative 2, which is 12. So for D it says, what is comparing from B and C? Tell us about this function. Well, that the rate of change is different. The rate of change is different for each x value, or each set of x values. Now, we have some of the points. We're just going to do like a little sketch. So if you look at some of the points we had negative 1, 4. So based on what we got here, looks like, and again it's sketched, so I'm just going to throw in some points. You got negative 1, 4, 0, 8, and we got 232. And again, these are all estimates. So we could take those few points that we had. You don't need to put all the points because it's not a grid. But what you can see is that this stays above the x-axis, and then what happens, it gets quicker, it rises quicker and quicker. So what you have is repeated multiplication in an exponential function. So that's why it's different than linear function, because linear functions are repeated addition. And we'll actually talk about that in a couple assignments from now. So what you have is, you have A, which is the y-intercept. So here's our y-intercept, like we talked about before. And then we have what's called a multiplying factor, because that's the number that gets multiplied over and over. So we're going to look at exercise 2. And you can kind of work on exercise 2 by yourself. We're going to resolve this here. And for a lot of the parts, they just want you to evaluate g of 0, g of 1, g of 2. And they give you the function above. And in the case of the most important part is when is it increasing and decreasing. So when we talk about exponents and exponential functions, the big thing is that when the multiplying factor is greater than 1, it will increase, and when the multiplying factor is less than 1, it'll decrease. So they can try to trick us some of the time, but if you look at exercise 3, it says for each of the functions, give its y-intercept and tell whether it is increasing or decreasing. So we talked about a being the y-intercept. So like this one has a y-intercept that equals 8, and this one is going to be a decreasing function. So we got a decreasing exponential. So if you look at b, y-intercept is 125. And then this one will be increasing because it's above 1. They try to trick us on C. Well, the y-intercept, like we just talked about, will be 56. And then this one will also be increasing. And it's not decreasing because it's a fraction, because this fraction, 3 over 2, would be the same as 1.5 if you divide that in the calculator. So if you're not sure if the fraction is above 1 or below 1, you can use the calculator to divide it. So that's the big ideas behind this assignment. And the last one we're going to look at, exercise 4, they want us to write the equation. So what we have to think about when we write an equation, kind of like we talked about linear, you want to think about where it starts. So you want to think about that y-intercept. So if I look at this table right here, I can find my y-intercept because the x value would equal 0. So I know my first number is going to be 10. Now, x is going to be my exponent, and they want me to find the multiplying factor. So what you got to think about is what are they multiplying each number by to get the next one? So 10 times what equals 30? 30 times what equals 90? So I can figure that out by dividing 30 by 10, and that's going to give me a multiplying factor of 3. So if I do 10 times 3, 30 times 3, 90 times 3, I'm going to see a pattern emerge. So again, like I was talking about, exponentials are repeated multiplying. So you got repeated multiplication going on. Whereas a linear function, like we talked about in Unit 2, would be repeated addition.